This is Calculus AB 2016 AP Exam Question 6. Okay, so you see here you have a lot of information. There's x, values of x, f of x, f prime, g, and g prime. Okay, so it says the functions f and g have continuous second derivatives. The table above gives values of the function and their derivatives at selected values of x. The first part of the question here is let k of x equal to f of g of x. That's a composition of functions. And they want you to write the equation of the tangent line to the graph of k at x equals 3. The next part of the question is let h of x be g of x divided by f of x. And they want you to find h prime of 1. And the last part is evaluate the definite integral of f double prime of 2x dx. Okay, it looks like this question is just all about if you understand the rules and know how to use them. There's not much thinking a problem out or anything like that. It's pretty straightforward if you know the rules. There's extra information up here that if you make a mistake down here when you're doing these, the values will be up here so that you'll get confused. So you got to be very careful with this. So let's go to the first part here. So the first part here says, wants you to write you're given this, it wants you to write the equation of the tangent line to the graph of k at x equals 3. So basically we want to know is the tangent line of k at the point 3. Okay? So to write the equation of a line, you need the point and a slope, just like you always have. So let's go one step at a time. So k of x is equal to f of g of x. They gave us that. So k of 3, x is 3, so x is 3 is f of g of 3. Now with compositions like this, just like with nested parentheses, you always do the inside group first. So we want to find g of 3. So you go up here to the table. Here's x is 3. You go across, and I just circled them so they'd stand out a little better. So g of 3 is 6. Okay, so you take g of 3 out and plug 6 as its value and plug it in its place. And so now we want f of 6. You go up here to 6. X is 6. You go across to f of 6. F of 6 is 4. So the point is x is 3. Y is 4. Okay, there's the point. Now, in order to find the slope, we got to find k prime. And that's the part they're really looking for here. They want to see if you know how to use the chain rule here. So k prime of x, this is a composition of functions, so it's going to be the derivative of f is going to be f prime of g of x times g prime times the derivative of what's inside, g prime of x. Okay? And let's just look at that for a second, because people sort of get confused with that. If I asked you over here, if I said y is equal to sine of x squared, see this is a composition of functions, okay, you'd say y prime would be the derivative of sine, which is cosine, of x squared times the derivative of the argument in here, which is 2x. So it's just like if sine is f and x squared is g of x. So the derivative would be f prime of g of x times g prime of x. You need to know this rule right here. That's going to be asked at some point, most likely on a test. Okay? So here we do, so k prime of x is going to be f prime of g of x times g prime of x. And then I want to know the slope on k at the point 3. So that would be x is 3, so x is 3, x is 3. So I need g of 3, the inside group first. So g of 3 was 6. Okay, we found that before actually. And then we plug 6 in for g of 3. And then g prime of 3, so here's 3, g prime of 3 is over here. It's 2, so g prime of 3 is 2. So now we got to look for f prime of 6. 6, f prime of 6 is 5. So we have 5 times 2 is 10, so the slope is 10. Okay, so the equation of line, I'm using point slope form, is y minus the y value, 4, equals the slope times x minus the x value, which is 3. And then the equation of the tangent line, if you wanted to just clean this up a little bit, you can just move the 4 to the other side. So the equation of the tangent line to the graph of k at x equals 3 is y equals 10 times x minus 3 plus 4. In case you don't know how to find the equation of a line using point slope, it's very simple. Most of you get used to using y equals mx plus b, and that's your forever. This is really a fast and better way to do it. And you probably say, well, I don't remember that formula. Well, you do know the formula. If you know that slope, most people know, you should know the slope is change in y over change in x. And then if I just multiply both sides by change in x, I get change in x times m equals change in y. I just switch sides, okay? And then change in y is just a change in the y points. So it's y minus y, the particular point you're looking for, equals the slope times change in x, which is x minus x point. So if you could just do these couple of steps, you know the point-slope form. And then if you want to, you just move this y point over here and it becomes plus. So if you know this, you just plug the x-coordinate here, the y-coordinate here, and the slope here, and you got the equation. Okay? That's pretty straightforward, pretty simple. Okay, the next part of this question is they're checking to see if you know another rule. In this case, we want to know what h prime of 1 is, so we want to take the derivative of h, so we got to take the derivative of this, which is the quotient rule. So you need to know the quotient rule. Now the way I do the quotient rule, so h of x is equal to g of x over f of x. The way I do it, because a lot of people make mistakes. See these two terms here, this is f of x times g prime, then it's minus g of x times f prime. So a lot of people get this backwards. And if you get it backwards, obviously the sign is going to be wrong. So the way I do it, so that I don't make a mistake here, I take the denominator. I start with the denominator squared, which is f of x squared. Then I take the denominator times the derivative of the numerator, minus the numerator times the derivative of the denominator. So I go denominator squared, denominator times the derivative of the numerator, minus numerator times the derivative of the denominator. Now I want h prime of 1, so x is 1, so every place you see an x, you plug in a 1, and it doesn't hurt. You don't want to skip steps. You don't want to be sloppy, because if you do that, this is not a hard problem, but you're going to make a mistake if you're sloppy. So f of 1, go back to the table, f of 1 is minus 6, okay, times g prime of 1, so here's 1, g prime is over here is 8, so it's minus 6 times 8, minus, we have g of 1, here's 1, g of 1 is 2, and then it's going to be minus f prime of 1, here's 1, f prime of 1 is 3, so it's 2 minus 3, so this becomes 2 times 3, excuse me. So this becomes minus 48 minus 2 times 3 is 6, which is minus 54 over 36. And if you simplify it, it is minus 3/2. Okay, that's what h prime of 1 is. Pretty straightforward. Now the last part of this question, I want you to do a definite integral, but a lot of people get screwed up here. You have to use u substitution. Okay, we know how to differentiate. As an example, if I ask you to integrate sine of 2x dx, we don't know how to integrate this unless we do a step in here. We know how to integrate sine x dx or sine u du. Okay, so we have to get into that format, into that pattern. So we have to use a u substitution. So we let u equal to 2x, then du is equal to 2 dx, du is equal to 2 dx. And then if I substitute back in here, this would be the sine of u, and dx is equal to du over 2, so this is du over 2, and you just take the constant outside. Okay, so we're doing the same thing here. So only this is a definite integral, so we want to know, so u is going to be 2x. If this was f double prime of x dx, you wouldn't have to do this u substitution. But it's a composition, so I have to do u substitution. So u is 2x, du is 2 dx. And now what you're going to do, you got to understand a definite integral, everything here is in terms of x. Okay, so if I'm going to use u substitution, I want now everything to be in terms of u. Okay, so this becomes, so I want when x is 1, when x is 1, x is 1, so then u is 2. And when x is 3, then 2 times 3 is 6, u is 6. So you do a u substitution for everything, and then you never have to go back. So this is 1/2 f double prime of u du, okay? That's where the dx is equal to du over 2. And then I'm going from, instead of 1 to 3, I'm going from, in terms of u, I'm going from 2 to 6. Now I don't have to go backwards, like I said. So 1/2 is a constant, and then the integral of f double prime is f prime of u, okay? And the limits are from 2 to 6. And again, don't go backwards, because everything's in terms of u here. So I want f prime of 6 minus f prime of 2. okay? And then f prime of 6, go up here, f prime of 6 is 5. Then it's minus f prime of 2 is minus 2. So it's 1/2 5 minus minus 2, which is 7. So it's 1/2 7 or 7/2. Okay? Now let's see what they gave you point-wise. You got 2 points for the slope. So basically they want to see if you didn't do the chain rule properly, you wouldn't have gotten a slope, correct? Okay? And then they gave you 1 point for the equation of the line. Okay, and here's the equation. Here's the value of the slope is 10, and here's the equation line. And if you notice, they use point slope form also. Okay, the next part of the question, you got 2 points for the expression for h prime of 1. So they wanted to see if you knew the quotient rule, and you had to substitute 1 in. And then the answer was just getting the data out of the table. Okay, in this part, I don't particularly like the way they do this. There's no need to do this, but they actually do use substitution, but you don't see what they did, and then they plug back in for x, and they leave the limits in terms of x. If you notice, they got the same thing I did, only they're doing it. If you're used to this method, I guess go ahead and do it, but it's going to be, it's 1/2 of f prime of 6 minus f prime of 2. You're just going back and forth when you do it this way, and you get the answer of 7/2. Okay? That's it for this question.